by writing down in mathematical terms what these different probabilities are.
When leading.
So when given leading.
Yeah, it's 0.9.
0.9.
Is that what I want? No. Other way.
Other way.
Yes.
Other way.
leading
So
wins.
when winning, that's kind of like the given. Given when winning, 90%.
Oh, I see. Oh, so it's the other way around.
So
Yeah.
leading-
So it got written a
Given
little
winning.
bit weird. Yeah.
So leading when winning. But I know that's gonna be a problem.
Yeah.
So it's
0.9.
I think I usually try to write given as a hint. I didn't do it this time.
And the leading lose.
When the team loses.
Leading
you
lose.
were leading at halftime. So losing given leading or something.
0.5.
Leading, given
What?
losing.
Where did you get 0.1
Wait,
from?
P-
No, it's
It's
0.5.
difference. No,
Oh,
no.
I was thinking this one would be
Is it the
converted.
one-
They
No.
won't, unless
No.
it's the
Oh, no.
thing on the right. They
Should be
won't.
one also.
Oh, never mind. That's
Yeah.
not the
Yeah,
one.
not
then.
leading.
Okay.
It's 1.5.
So
No, this is
So
yeah,
what does he
leading
write as the
lose.
given?
Leading
okay.
lose
Okay.
and 0.5.
Given they okay.
Yes.
Can you see that?
When you think about the given, think about the stuff that's already happened. So when
Yeah.
the team loses, that's already happened. 50% of the time, they're leading at the halftime.
Okay. So then if we did okay.
So now what's the question? So what's the the mathematical statement we're asking?
Is it
in the
more
problem?
likely? Yeah. So this is the greater
Leading
than.
halftime.
Yeah.
Just
will
set up the Bayes equation for both.
Or let's start with something a little more simple. So we're asking, is the probability that they win, given they're leading,
Mhm.
Given they're leading. Greater than the probability.
lose greater leading.
yeah,
Yes.
is it greater
The
than?
relation between the greater and lose be
And
probability
then
of
replace
lose
them with
given leading.
lose per one leading,
Losing given leading.
Yeah, there we go.
and then replace it with the Bayes theorem.
Okay, so then
Yeah.
and then we do that theorem we did in class.
Yes.
Yeah.
P-
Okay, so let's write Bayes theorem. This is always good to do. You should do it on your exam. So I'll just read it off. The probability of A given B
Actually, memorize it.
is equal to the probability of B given A
Time
Times
probability
BA
of
over
no time
PB.
probability of A.
times A
Yes,
divided by B.
What did I say?
Okay, so I'm going to
Okay.
highly suggest you ingrain this equation in your head, that you don't even have to think about it or look at your paper. Okay, so if you have to think about it or look at your paper to remember Bayes, you're already losing on this exam. You're adding time in a place where you shouldn't be adding time.
But we have to write it down, right? Like the formula.
I think it's a good idea to just write that equation down. Yeah, I would do that. I suspect I probably did here. Did I do that? Oh, I didn't. But you should. Again, don't use my examples as, yeah.
Oh, sorry, it's getting crowded.
Well, we can do it on another line. That's
Yes,
okay.
we
Do it
can.
on the line
Go
below.
down.
Yeah.
Well, because I'm
Over.
about to do the
Over P leading.
okay. P leading.
Yes.
Now you have to go for
So I think
lose
I-
leading.
This.
No, you have to go for lose leading. Leading loss also.
Can I suggest that you put that,
Yeah,
like,
don't
follow
simplify
that
it.
structure of the less than or equal to?
Yeah, you can.
I'll say, you know what I'm talking about?
Put it here.
Yeah, put it underneath.
Oh, okay. Oh, okay.
Yeah.
Start underneath that.
But don't set it equal to. Set it with the
No,
greater
yeah,
than.
not the, no.
Yeah. So you can just go right to Bayes.
So right here.
Yeah, right
So
there.
then do probability of.
Leading? Yeah.
What about if I wanna keep writing winning and leading? Can I just be like win is A, leading is B?
Or can you do like
Leading
L or
the
W?
win.
Yeah, like that. Like just
Just
declare
be
my-
careful as long as it makes sense.
Okay.
Yeah.
Yeah, leading win.
Yeah, you had it. Probability of leading.
I know.
Yeah. Oh, okay.
Changing it to abbreviations.
Over probability.
Oh, just be careful because
No,
Oh, yeah,
but
you're gonna have
no,
lose and
be leading.
Ah.
Be losing. No, no. Just keep it low. Keep it all. All
We're going like that.
But then, okay.
No, but
Keep
you
it-
have
yeah,
to
that's
multiply.
fine. That's fine.
We'll change it later.
No, but you have to multiply by probability of leading.
No, just
No, yeah,
keep going.
yes,
Keep going.
keep
You're
going.
good.
Okay. and then
Yeah.
these
And
cancel out.
Can you put the relationship question mark? Yeah, there we go. Okay. Is there another black marker? That one's becoming a little bit dim.
Yeah, there's.
Okay.
This work.
So you canceled out both the bottoms, right?
Yeah.
Okay.
Now we have everything.
So now you have everything. So you can start plugging
leading
numbers in.
one.
0.9 times 0.75. 0.5 times 0.25.
That's like, and put the relationship still with the question mark. All right. So if you multiply those two numbers, you get. Oh wait.
It should be 1 minute.
Wait. When meeting. Why do I have a completely different? Oh. Is that what you said? Okay. Yeah. Okay. Oh, sorry, reading the wrong problem. Okay, so 0.675 on the bottom. Left, yeah. And 1.25 on the right. Okay, so is that true or not?
That's false.
Oh, 0.125. 0.125.
Okay.
Should be less than 1.
So it is true.
Yeah, so I like to put a little check mark right over it. Or you could say true. Okay, cool. So we got the first one done. So how bad was that?
We're at 7 minutes 40 seconds.
We could have went faster too.
Yeah, you could have gone faster, right? So there's a problem you should knock out, I think, in very little time.
So first of all, from what I'm saying here, the test will be 3 questions on Tuesday.
4 questions maybe?
Since the number 2 isn't something we
Oh,
cover.
so, yeah, but I'll give you just a different question.
Extra credit?
No, different question.
You had extra credit on this one. Is that
Yeah,
something
yeah.
you normally do?
No, still number
Depends. Usually nobody can get it. Oh, so here's a good question. Like,
3. But we haven't finished number.
so show that all 2x2 comparison matrices are consistent.
Oh, can we do that one?
Yes.
Let's finish this problem first.
Because xij equal 1 over xij here. X1 x.
Hold on. Let's focus on. Alright, so what was the other question?
Team are losing at halftime.
Is it more likely they lose the game? So, can we jump right into like where we were right
Yep.
here on the last one?
Yep.
Okay.
The team is losing at half.
So that one's going to be probability of win.
When
Given
Given losing, yeah. So we want to find that. Is it more likely they win or lose the game? Probably win.
Oh, correction. You should have written the equation above it, but that's fine. We don't do it now.
Well,
That's
I'm about
okay.
to erase it because
Yeah.
I didn't start.
Okay. Yeah, I would have written the other thing, the first line.
The
Probability of winning given losing.
Losing.
Okay.
oh, I see.
But not losing first half, not losing. It's a losing first
Yeah,
half.
so I.
Because we have to lose now.
So sorry, you should put probability of win. Maybe if you're going to keep the notation that you've been doing. So the probability of win given losing, right, times the probability of lose, LO, given losing.
Yeah, okay.
And jump straight into.
Good. So at this point, here I feel more comfortable if you start just plugging numbers. Like if you're to write Actually, well, just do it. It doesn't matter. Never mind.
This is 0.1.
Mm-hmm.
So
Time
okay,
0.75.
because it's the opposite.
Yes,
Yeah.
0.1 times 0.75. 0.5 times 0.25.
And that one's what? Point. Is that 0.07?
0.75 and 1.25. 0.125. Yeah.
So that's false.
So it's more. So here you would say it's more likely they lose the game.
Okay.
Okay. All right. So 10 minutes.
Decent.
Should be able to do it, and I think if you could do this problem in 10 minutes, you'd be fine.
Well, I feel like if you practice this a couple times, you should be able to bang it
Knock it
out
out,
super
and yeah,
fast.
super fast. Yeah, but
'Cause
again,
it's
it's an exam, so like,
yeah.
people respond a little bit differently. So if during the exam you could read the problem and then solve it within 8 minutes, you're doing real well. Ask your question again.
Could you just simply set up a decision tree instead of introducing Bayes' law at all?
So in fact, what Bayes' law is doing is doing the math of the decision tree. Yeah.
So no.
So yeah, I mean, you don't need the decision tree. The decision tree is more the visual to understand what Bayes' law is doing.
Yeah, you could get the same result, but for your technicality of scoring.
Oh, I didn't care about the drawing the decision tree. Yeah.
But would we need Bayes' law in order to get credit for the problem?
Oh, you absolutely need.
Okay, that's
Yeah,
what I'm saying.
Bayes' law is the only way to solve this problem. Yeah. Okay. We're good? Any more questions about this one?